Welcome to qnawire.
Okay, so I've got C5H13N. And before I do any sort of NMR stuff, I'm going to calculate the double bond equivalencies to find out if I have any double bonds, which you can pretty much, it's always a good idea to do that before you start looking at any spectra. So the formula is the number of carbons minus the number of hydrogens over 2. In this case, we've got 13 hydrogens. Plus the number of nitrogens divided by 2 plus 1. So this is like 5 minus 6.5 plus 0.5 plus 1 equals 0. So we know we don't have any double bonds in our molecule. Great. Totally unsaturated. Double bonds or rings. Now, we're shown these peaks in ratio of 4 to 3 to 6. Okay. So that's nice because we've got 13 protons, which means that we know we've got 4 protons of one type, 3 protons of another, and 6 of another, right? We also know from the fact that we've got 3 peaks that we have 3 sets of chemically equivalent hydrogens, right? So it starts to rule things out. Like, right, we couldn't have a chain of 5 carbons and then an NH2. That would be too many. We would expect too many peaks, right? We'd have 1, 2, 3, 4, 5, 6 different hydrogens, and we've only got 3 signals. So what that tells me is that we can expect some degree of symmetry going on here, right? Like, it would be, it's totally necessary. Basically, because we've got only these 3 signals, we know these hydrogens are arranged in such a way that there's multiple groups of hydrogens that are identical to other ones. Okay, so we're looking at some sort of molecule with some kind of symmetry. Okay, and then finally, if we look at these spectra, I can't zoom in on them, but to me it looks like this is a multiplet of some kind. This is well, we don't know if they correspond to 4, 3, and 6 in that way. Sorry. So, oh yeah, left to right. Okay. So this is a multiplet. This is some kind of singlet, and this is another multiplet, right? So whatever's causing this signal, we've got 3 protons that aren't next to any other protons, right? So that could be like a methyl group, right? And then this carbon, so we've got 3 protons here. And we know this carbon can't have any hydrogens on it. Otherwise, we would not have a signal whose integrates to 3 protons that's a singlet, right? So this is where I'm going to start. Then we got to figure out what this 4 and this 6 are. Okay. One final thing worth considering is that we don't necessarily know if this is a carbon. It could be the case that this is a nitrogen, so long as that nitrogen doesn't have hydrogens on it. Okay. So the next thing I'm going to look at is I can roughly make out the shapes of the peaks without zooming in on them. And I'm fairly certain this is correct, that the 4 on the left, it looks like a quartet. And the 6, the peak that integrates to 6, looks like a triplet. Okay. And whenever I see quartets and triplets in the same signal, I think CH2, CH3 with something else over here, right? So this hydrogen, 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 right? Because if we call these protons A, and we call these ones B, we use the N plus 1 rule, we know that A has N equals 1, 2, 3 plus 1, 4 splits, right? So that would make it a quartet. It's got 3 neighbors, so N plus 1 tells us 4 equals a quartet. So we expect this to be a quartet. And if we look at hydrogens B, we count the number of neighbors, 1, 2, and we add 1, N plus 1 equals 3, which tells me that hydrogens B should look like a triplet. And we do have a quartet and a triplet. So it's very, it's likely that those are causing each other or splitting each other, right? And we have no other signals in the entirety of our spectrum. So we can almost guarantee that whatever protons are responsible for this signal are neighboring the ones that are responsible for this signal. Okay, so now I've got some more stuff. And we also know that whatever is here does not have any protons on it. So we're kind of in a similar situation where we were with the methyl. It's like we know that there's no carbons coming off of this either of these green things. The other thing is that because this integrates to 4 and this integrates to 6, I think I've got another one of these ethyl groups, right? Let's not make that green. Dot could be green. Right? This looks very likely. So I've got essentially 2 ethyl groups and a methyl group just floating around connected to something that doesn't have any carbons or any hydrogens on it. And if I start to total these up, that's 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon. Well, I'm out of carbons. So maybe what this green thing is a nitrogen. Well, that kind of makes sense. Let's explore that further. If I had a nitrogen with an ethyl group and 2 methyl groups, right? I've got my 3 hydrogens here that have no neighbors. I've got 2 hydrogens here that have 3 neighbors, 3 hydrogens here that have 2 neighbors, and there are 2 of the pair of 2 hydrogens and 2 of the pair of 3 hydrogens. So the 4 and the 6 makes sense. This is my structure.